Hi Wilson. Hi Parimal. Hello Naveen. Hi Amit. Hi Harish. Hi Lavanya. Hi Pradeep. In couple of minutes we will start the session. Hi Saurabh. Hi Seetala Sandhya. Hi Saravanan. Hi Timir. Hi Pankaj. Hi Kate. Hi Abhijit. Hi Sridevi. Welcome to class. Hi Abhijit. Wilson, you facing any issue? Okay. Good afternoon everyone. We will start the session in 1 minute. Fernando, still hearing background voice?
All right, so Arjun,
Yes,
shall
sir.
we get started?
Yes, sir. Please.
All right, thank you. Hello, everyone. Very good afternoon. Welcome to AWS webinar series. Let me share my screen. Guys, please confirm if you're able to see my screen. If you're able to see my screen and my voice is clear and audible, so please acknowledge. So I'll proceed. Fantastic. Great. Hope you all had a good weekend, and glad to meet you again, once again. So today, we are going to talk about the networking services. So in our AWS webinar series, so we already talked about uh, the basics about AWS and AWS computing service and storage service. So today we are going to talk about networking service. In that, we'll just see what are the different networking services are available, and in the within that, especially we are going to focus on VPC, virtual private cloud. Okay, we'll learn the concepts related to VPC, and we will see a hands-on demo how to create a VPC and how we can like enable the networking for the EC2 instances which are going to launch in AWS. And also we'll have a quick overview about the career options and the further certifications which is available in AWS, which you might have already gone through earlier. I think for time being, I will also skip this intro. It'll be very short. I'm Saravana and specialized in cloud computing, big data analytics, and microservices. And I'm sure all of you know about me now. And let's have a quick overview about what's AWS. It's again, Amazon Web Services is a secure cloud services platform offering cloud compute power, database storage, networking, content delivery, and other functionality to help businesses to scale and grow. Out of this, we already discussed about compute power and the storage, and today we are going to focus on the networking, right? So these three are foundational services. So at a very high level, these are the categories of different AWS services available, and out of this, the foundational services are going to be compute, storage, and networking. Okay, networking and delivery, content delivery, right? So today our focus is going to be on networking. And so just to quickly recap, so far we are discussing about AWS cloud and the different compute, storage, and security configurations available in AWS. So if you want to map with the traditional infrastructure and which one has been got transformed into a different AWS services in the cloud, if you just look at this diagram, this will give a good overview. So like the data server, the on-premise servers which you are running in your data center would be transformed into AWS EC2 instances and with AMI, Amazon Machine Image, right? So whatever workload you're running on on-premise servers, that I can able to put it into AWS EC2 instances. We already seen how to launch and how to configure EC2 instances. Then when it comes to the storage space, like we have a bunch of storage options for a traditional IT infrastructure. So the DAS, it's direct attached storage. Okay, so which is something like the hard drive which you can directly attach, or any hard disk which you can able to directly attach to the server. Then we have NAS, network attached storage, so wherein I will have a dedicated storage server and that can be just accessed over a network. Then you have a SAN, storage area network. So in that I'll be form a cluster of servers which offers storage in a distributed way, right? So these are the different storage options. Wherever the storage of data is little less, we'll go for a DAS, and if it is more, slightly more, and I want to share the data across the different servers, which is running on premise, will go for a NAS, or if the volume of data which I want to store it's really high, the SAN will go. And in case, so this all provides the the storage in a file system. If I want to store the data in a more organized way, we'll go for a RDBMS or any NoSQL databases. So the database is more storing the data on organized format. So when it comes to the AWS, we have the equivalent services which is available to cater those needs. We have a Amazon EBS, which is something similar to the DAS, direct attached storage, or a hard disks, what you have in your computer. And we have a Amazon EFS, Elastic File System. So that is something similar to the NAS, whatever the NAS provides. And Amazon S3, it's something unique, which directly not relate to any of this one, but actually, so technically we can compare it with the SAN when you want to really store a huge amount of data, and also it enables you to access the data over the internet. In case if my data is I want to store it in a database, so still I can able to run the databases in the AWS as a managed services. So with the help of Amazon RDS service, relational database service. So with Amazon RDS, I can able to run MySQL or SQL Server or any standard RDBMS. Okay, so the provisioning, the storage, and managing and the infrastructure for running those AWS like a database servers would be taken care by the RDS service. And similarly, if I want to run any other NoSQL databases, we have equivalent services. Like if I want to run for example, MongoDB or a Cassandra or Elasticsearch, we have equivalent services in Amazon to run all those things. Fine. That's with respect to the storage and the database. And when it comes to the networking, here in the compute, so I have a requirement to create 100 servers. So I can easily create 100 EC2 instances, not a problem. But I want to have some kind of a networking within that 100 servers. So I want to define, I want to logically divide that 100 servers into 20 servers each. Okay, so the first set of 20 servers will be used by one of the team, and that requires some specialized only the access to be allowed for certain group of people. Okay, and the second set of servers, I want to allow a different set of people to access the servers, and also I want to put a different set of networking rules and the security restrictions for all these different set of machines. So how do we generally do that? So normally, if you see, if you are going to do a physical networking in your hardware your IT infrastructure, so when you have a bunch of servers, when I want to connect the servers with each other, we'll create a networking pipeline, and we will just bring in switches and routers, and that will take care of routing the request from one server to another server. If the servers resides in the same LAN, local area network, then the communication between the servers is going to be local communication. In case if the server needs to access the content from over the internet, okay, then it should have some kind of a public access, right? So we will configure the router to allow, or we may need to set up the proxy and DNS. Few other configuration we need to make in order to make these servers accessible over the internet. Okay, but overall, if you see in the traditional IT infrastructure, we'll have a like a network pipeline which is built with a bunch of routers and switches. On top of that, we will have some firewalls to restrict the access. We'll have some proxy servers, and we will have some DNS servers, so to do the naming resolution and routing the requests. And the routers will have basically some rules on what basis the request has to be routed, right? So when it comes to the AWS, so how I can able to, so here actually I can't create a physical network, I can only create a virtual network. So already I created virtual server instances, Within that virtual server instances, if I want to bring a virtual network, so that if I out of 100 servers, I want to logically group the servers into different buckets. I want to apply a different set of access restrictions, access control for each of the group. And how I do that? So I can do that with the help of VPC. So VPC stands for Virtual Private Cloud, and I can create a scalable network, high performance network in AWS with the help of VPC. Cool. Then there are a few other concepts we have. So that is something like a elastic load balancer. Whenever I want to elastically like when the request comes, if I want to kind of load balance the request, so I'm having 5 EC2 instances running. For on all the 5, the same application is running. When the request comes, I want to load balance the request and route that request to one of the 5 instances based on the load. So how we can do that? Traditionally, we have like the load balance like FI or some load balancing appliances we may have, or there are some load balancing softwares we have. So when you're going for AWS, you have an elastic load balancer that will take care of handling the load balancing for your applications. Again, the load balancing, I can do it at an application level or at a networking level. Okay, and along with the load balancing, I can also make use of another concept called auto scaling. So whenever the load increases, currently I'm running 5 instances of EC2 server for running my web application. When the load increases, I want to increase that 5 instances to 10 instance, or 10 instance to 15 instance automatically. So I can able to achieve that with the help of another concept called auto scaling. So that is one of the key and a very useful feature with AWS. That again, when I'm going to scale to 15 instances, this load balancer will work out of the box. That now earlier I had 5 instances to load balance. Now when it increases to 50 instances, now when the request comes out of the 15, the load balancing will happen automatically. And whenever I want to, whenever the application load decreases, then it can automatically scale down. From 15 instance, it can come to 10 instance. From 10, it can automatically come to 5 instance. So this will help me to bring the elasticity, scalability for my application deployment, and also it helps me to reduce the cost. So instead of I'm always running a more number of servers to handle the peak loads, I can able to spike the number of instances only whenever the load increases or whenever I'm getting spike, right? Cool. Then with respect to the security, in the traditional infrastructure, we have firewalls and ACLs, the access control list, and we have some kind of users and groups will create and delegate some permissions to that. So with respect to the AWS, we have security groups. This we already seen along with the EC2 computing service or EC2 instances. So this security group is kind of acting as a firewall. So instead of having a local firewall on your individual instances, I can able to control that instance access with the help of security groups. There I can configure the inbound or outbound traffic. Then if I want to do that configuration at a network level, so I have a network of 20 machines, and for the entire 20 machines, I want to put a control. Only a specific team or a specific set of users should be able to access any of the instances within that VPC. So that the entire network level access control I can put in the form of network ACLs, NACLs, right? So this NACLs will work with VPC. Then we also have AWS IAM, Identity and Access Management, and with the help of this particular service, we can able to create a set of users and assign some roles and permissions, and based on the roles and access given, he can able to access or we can allow or restrict the access to different AWS resources, right? So these are the when you're comparing your traditional infrastructure and how that same infrastructure will be replicated in AWS cloud. So this is the comparison which just shows how the existing the traditional devices or services or the infrastructure what you have can be uh, like provisioned with the help of AWS services. And today we're going to focus on VPC. Let's get in networking service. So basically, under networking on the content delivery, we have a bunch of services, and first and foremost in that is a VPC. As uh, as I mentioned earlier, it helps to create a the virtual networking between the AWS instances. And we have another one called CloudFront. So this CloudFront is basically a part of content delivery. When I say content delivery, when I'm going to host a big web application and I have a user base across the globe. For example, I hosted a some kind of a for example e-commerce portal in India, okay, in Bangalore region, and I have a user bases across Europe and US. When when the users accessing within India or within Bangalore, it will be the application will respond faster because the network latency is less. When the same application accessed from Europe or like US users, there may be a lag in the performance. So how do you overcome that problem, or how do you avoid that lag? That's where that CDN helps to do that, content distribution network. So the concept of CDN is basically, so whatever the resources you're going to access from your web application, right, all the static resources, so images and the HTML files or JavaScripts, all the static resources would be cached in the for example, if there are a set of user bases are there in Europe and a set of users are there in US, so in that Europe region or US region itself, this resource will be cached, so that whenever that user is accessing, it won't come to the Bangalore, the server running in a Bangalore and all time. It just loads the resources from here to there. Instead, it will try to serve most of the things, the static data from the cache itself. Only for the dynamic things, it will come to the server located in Bangalore and will try to serve the request. So that concept is basically CDN, content distribution network, that's very widely used wherever you have a big web application or any internet application which needs to be accessed across the different locations and regions across the globe. And so that concept we call it a content delivery. So this will ensure, regardless of wherever you're going to access that application, it will be giving the same performance. You won't find any lag or any difference in the response time, right? So you can achieve that in AWS with the help of CloudFront service. This CloudFront service is providing a implementation for CDN. Okay. Then the other typical requirement would be, I may have a I already have a data center. I have a bunch of servers running in my own data center, right? And I also have a bunch of servers running in AWS. So I want a seamless connectivity between the servers running in within my data center to the servers running in the AWS cloud. So, typically, if you see, we need to access that over the internet. So whenever, for example, I'm having my database running in my local data center server, the local data center, and I have my web application hosted on a AWS cloud. So the web application, whenever the user is going to perform any new addition of record or updation or deletion, any CRUD operation, it has to interact with the database. So from your AWS, the interaction to the database will happen over the internet. So there is a possibility there could be a lag between the the data the IO operation with your database. This basically a kind of a hybrid setup. We have few servers running on a cloud and few servers running in a local data center. Mostly for a compliance and security purpose, the critical things we'll try to run it from a local data center. Fine. So in this case, how do I improve the performance? The one way is using the direct connect. What the direct connect will enable to do is create a direct connectivity between your data center and to the AWS cloud. Once the direct connectivity is established, it's more like a lease line between the two different networks, your local network, enterprise network to your AWS network. So when that is established, the servers can able to interact with each other, and it will provide a very fast or a very so that speed of the interaction would be really very fast. Then you have another service called Route 53. So this Route 53 is basically, if I'm going to host any web application on AWS, I want to make that web application to be accessible over the internet, made it public. Okay. So if I want to make it public, what I need to have a domain name for my web application. So normally there are a lot of domain providers out there. So you can go and register and get your domain name, right? And on a yearly basis, you may need to renew your domain in order to keep the same name. So we have something like GoDaddy and the naming.com. There are a lot of people, the DigitalOcean, a lot of people providing the domain naming, web hosting and domain naming service, right? So if I'm using AWS as a web hosting, so I might require a domain name service as well. So either I can use a third-party one, or AWS itself, they're offering their own domain naming service, DNS service, that is Route 53. So using this Route 53, you can register your domains with AWS, and using that domain, you can able to access your web application running on the AWS cloud. And even it's possible, your application can be hosted on-premise. I can just register a domain with using a Route 53, and using this domain, I can able to access any application which is accessible over the internet. It can run on AWS cloud, or it can be running on-premise or a different cloud also. It does not matter. So this basically provides a domain naming service. Even if I have a domain already in GoDaddy or a DigitalOcean, can I able to migrate to AWS? It's possible. So you can able to migrate the existing domains into the Route 53 as well. So these are the key things. If we see here, VPC is provided typical networking facilities. Okay, like you create VLANs, virtual LANs, and say creating some subnets and everything. The routing, configuring the routing rules, configuring the like a network level security, access control list. Everything you can able to do with the help of VPC. And CloudFront is just providing a capability to make your data distributed to a different region, so it will improve the overall performance of your application, or it will basically enable the users across the different locations to access your application without any performance lag. And the direct connect basically enables to make the your enterprise network or enterprise data center to connect to your AWS data center, so the servers running on-premise and the cloud can able to interact with each other in a very fast and reliable manner. And Route 53, it provides a domain naming service. So out of this, let's focus on VPC today, right? So VPC basically, like as the name suggests, it's a virtual private cloud. It provides the scalable networking capacity in the Amazon Web Services cloud. So you can provision a private isolated virtual network on AWS cloud. So see, when you're going to provision a EC2 instances in AWS cloud, it's possible like I don't want to expose all the EC2 instances to be accessible over the internet. So I can create a group of EC2 instances to be running as a public instance, to be running as a private instance. Few of them could be public. So typically, if you see an enterprise, I may have a lot of intranet applications, right? So I will be having some kind of employee portal, some payroll processing, the HR management system. So those are all like the intranet portals. So those things I don't want to really make it accessible to everyone. I can still run those things under private network. So only the people who are getting connected to the corporate that enterprise network should able to access. So whereas the other things, so I may have my company's website, or I may have some product, for example, some e-commerce product, or some other like a CRM product or ERP product, and which I want to make it accessible for the public to use. So those cases, the servers which hosting those application need to be exposed to public, right? And this VPC provides with the help of VPC, either I can create a private networks or a public networks, and also I'll be getting a complete control over the virtual network which I'm going to create. Let's see. Um, so let's. So basically, when you're going to create a VPC, so it's like the VPC will have a set of subnets. So you can think of something like this. So when I'm going to create a, so this is my VPC. Okay, so I have a bunch of EC2 instances. So instance 1, 2, 3, 4, 5. Okay, so what I can do is, so I can make these two instances to be part of one group. Basically, if you see, this is my at a very high level. So this is my AWS cloud. AWS cloud is something like accessible over the public, over the internet, right? AWS cloud, and in this, so this is my VPC. So I can say this is something like, this is my VPC. Then it's also possible, like we can have an multiple VPCs within the private cloud. Okay, so this is like this is VPC 1. This is some other VPC. VPC 2. Okay, so this VPC can have a bunch of machines. So it can have a bunch of servers. Okay, so what I can do is I can actually restrict the, so I can make when I'm going to create my own VPC with a bunch of EC2 instances, I have a full control on this, that who can able to access the instances running within this particular VPC. I can allow only my team or only the authorized people to access these instances, and similarly I can able to restrict, so the instance running in the other VPC cannot access. I can either allow or restrict. So the complete so apart from the authorized people, the others can be able to access your instances. This provides like more control and also security for your instances. And on top of this, I have 5 instances. I want to like organize these 5 instances into 2 different groups. Okay, so one group wants to access to the internet. So like this is something like in these 2 servers I'm going to run some internet facing applications. Okay, so so which means these 2 instances needs to have access to internet, needs to be accessible over the internet, whereas the other 2 I can make it as an internet. Okay, so this would be some intranet applications, or I would call this as a private. So this should not be accessible publicly. because here I'm going to run some the organization specific applications which need not to be exposed to our public. Only within the organization network I need to access. So this, the other terms, I will call this as a public network. So how you can achieve this one? So in the one VPC I can create multiple subnets. So each subnet is a group of EC2 instances. Each of the subnet can have a set of roles. So in this VPC I have two subnets. Subnet 1 and this is subnet 2. Okay, so this subnet 1 is public subnet, so that means the instances running within this subnet can be accessible publicly, whereas the subnet 2 is a private subnet, so the instances running within this cannot be accessible over the internet. Okay, and so likewise I can create any number of subnet. So the one usage of subnet is to designate whether the instances running within this instance needs to be accessible over the internet or not. The other one is like I can have my own address range. So I can say like this subnet is having some specific address range. For example, 10.0.1.0. Then this subnet I may have a different address range, 10.0.2.0. So in order to organize and your instances, I may have a different set of subnets, and each subnet can have a specific IP range. Okay, and this range, whatever we are providing, this should be matching to when you're creating a VPC. I will tell. So what is my overall IP range? Here I would say like I'll be providing something like this. So this we call it as a CIDR block. Okay, classless interdomain block. So this indicates how many instances I can create within this VPC. Okay, so when I say, for example, 32, it is like, so the normal the range of values we may get for this one is so 32 to 0. Okay, so when you say 32, so this 32 is equivalent to 2 to the power 0. Okay, so it's totally 32 bits. It ranges from 0 to 32. Okay, when you say 10.0.0.0/32, that means this VPC can have only one machine. /32, this is a subnet mask. This indicates one machine I can have. When I say 31, it will be 2 to the power like 1. So 2 machines I have. So when I say 30, this is 2 to the power 2, 4 instances I have. Okay, so depends on how many instances I want. This actually we can provide. Okay, so if you say 16, it is like 2 to the power 16. So almost like so if you just compute 2 to the power 16, so whichever the value you're getting, that many instances you can able to run in this. So this I can able to further divide into different subnets. Okay, so for example, I have as a simple case, if you say 2 to the /28, so which means so so this is equivalent to 2 to the power so 2 to the power 4. Okay, so I can have so so total 16 instances, right? So /28 means 16 instances I have. So in this case I can say like this can have 8 instances, this can have 8 instances. Accordingly I can assign the addresses. Okay, so the VPC will have a specific CIDR block that can be further divided into multiple subnets. So if you are creating a VPC with 50,000 instances, that you can able to divide it. Cool. So let's get in. So this illustration shows. Sorry, not here. So the subnet defines a range of IP addresses in your VPC. You can launch AWS resource in a subnet that you select. A private subnet should be used for resources that won't be accessible over the internet. A public subnet should be used for resources that will be accessed over the internet. Each subnet must be reside entirely within one availability zone, cannot span zones. If you remember, each region in AWS has specific number of availability zone. Each subnet which you are going to create, that will be specific to particular availability zone. Okay, if you are taking a Mumbai region has 3 availability zones. So I can create up to like 3 subnets on the VPC which I'm going to create in Mumbai region, and each of the subnet I can map it to one of the availability zone. So this is the illustration which I was trying to show there. So if you see, so I have a, so this is my entire VPC, the AWS, and this is a VPC. And inside the VPC I have 3 different subnets. One is a public subnet. The instances running within this can be accessible over the internet. Okay, then the other one is a private subnet. This will be accessible only within the the enterprise network. Okay, and the other one is a VPN only subnet. So these instances can be accessible only over the VPN. Okay, and if I want to access it over the internet, I need another component like internet gateway that will be configured to make these instances to be accessible over the internet. If I'm going to access it from my enterprise data center, so I need to configure a connectivity between my my enterprise data center or the customer network to the AWS network. That configuration will be achieved with the help of virtual private gateway, or BPG we call it. Okay, so this will have the details about the connectivity between your customer network and your AWS network. So with that, we can able to make the AWS instances accessible from your direct data center directly, which is not accessible over the internet. Only from your data center it can be accessible, or I can able to configure these instances can be accessible only over the VPN. Okay, not over any other network. Okay, so if you look at the overall the Amazon VPC stack, so you have public subnet. So this instance A, B belongs to public subnet, C, D belongs to private subnet. So this running on one availability zone, this is another availability zone. Okay, fine. So there are 2 subnets I have. So subnet 1 and 2. Okay, and when you want to access it over the internet, with the help of the internet gateway, I can able to configure and make it accessible over internet. If I want to accessible within the corporate network, or over the VPN with the help of virtual private gateway. Okay, and the direct connect which I was talking about earlier, right? So using the direct connect, I can enable the connectivity between your corporate office to the AWS network. Okay, or if I'm going to enable over the VPN, so through when you enable over a VPN, I can able to access it over the internet, but only it allow the connectivity over the secure channel. Okay, so the people who are authenticated, who have access to the VPN, only they can able to access it. So the different components what you see in the VPC are internet gateway. The purpose of the internet gateway is enable the internet connectivity for the instances running within the public subnet. And VGW, that is a virtual private gateway. So that resides here. In case if I want to enable the connectivity between my AWS network to my corporate network, okay, then in that case I need to set up a VGW, virtual private gateway, that provides the connectivity. Then the subnets we have seen, that's a group of machines, group of EC2 instances. with running on a specific availability zone and with specific connectivity, either public or private. The direct connect, it enables the direct connectivity between your enterprise data center to the AWS. And the VPN, we have a different type of VPNs are there, hardware VPN or a software VPN and all. And if it is a hardware VPN, it's like, so the way you are working from home, so you'll be generating a token, and using the token you're able to connect to the machine, right? Same way when you set up a VPN to your AWS instance, and if it is a hardware token, you should have some kind of a hardware token with you that should periodically generate a token. Using the token, you can able to establish the connectivity. If it is a software, the same token generation can happen with the help of a software. Okay, then you have a set of security groups and ACLs to control the access. Let's quickly see how to create a VPC and launch so let's launch few EC2 instances and align the EC2 instance to a specific VPC. How to do that? And by default, when I'm going to create a VPC, right? So by default, when I'm going to create a, so the moment when you have a account registered with you, so for example, I'm getting into my AWS management portal. So let me log in there. Log back in. So I'm using the same account which we created earlier, using which we launched the EC2 instance and also the different storage services. All right. So let me connect, and let's see like how. So before let's go and see how to create a VPC. So these are the different networking services which we talked about: VPC, CloudFront, Route 53, Direct Connect. There are a few other things on there. API Gateway. It's basically if I'm going to build any microservices, I want an API Gateway to use that one. These are all related for microservices thing, App Mesh, and API Gateway. So all right. So if you actually go to the EC2 instance, right? If I'm going to launch a EC2 instance, so earlier I launched the EC2 instance. That time I didn't provide any VPC, right? I didn't have any VPC. So what happens is, so by default it shows, the moment if you see the EC2, it shows like actually in the older version of AWS, they didn't have a concept like what they have done is they had one single network of all the instances which is launched in the AWS cloud. For example, in the older version of AWS, if there are three different clients launching their EC2 instances, all three will be running on the same VPC. Okay, that means each one can able to expose to each other. Okay, so that we call it as a EC2 classic, that the VPC was not there. If it is a older account, you might see here supported platform as a EC2 classic, but for now all the new accounts you can see a VPC. When you see VPC, what does that mean is, the moment you have a AWS account and whenever you log in into your account and you're going to launch any instance, the instance which you're launching will be automatically like so there will be a default VPC created for your account. For every AWS account you are going to have, there will be a separate VPC, and whatever the instance you are launching, that will be associated to the default VPC. Okay, for example, if you consider this is your default VPC. So if we have 100 accounts, each account will have a separate VPC. And what is the VPC detail? This is the default VPC. If you just go there, you can actually find the VPC detail there, the default VPC. Okay, so whenever you are going to launch a EC2 instance, it actually uses the default VPC. Okay, so the default VPC details would be there here, and how it's being used when you're going to launch the EC2 instances. So during the launch wizard, if you remember, the instance configuration step. So as part of the instance configuration step, we need to choose that which VPC I want to launch. For example, I want to launch a Windows machine. So first step will be choosing the instance type. For example, I'm going with the T2 micro. The configure instance is there, right? You just look at this. This is the network configuration. And in the network configuration, what happens? By default, it lists all the VPCs available within the account. Currently, this account has a default VPC. Okay. So whenever you're launching, this instance will be associated to this VPC. And the VPC can have multiple subnets, as I mentioned. Okay. And this VPC has 3 subnets. Okay. I can choose which subnet this instance I want to put. And auto assign a public IP. So what does that mean is, like, when you just enable this one, so it will ensure it will create a public IP. If it is a public facing subnet, the instance which you are putting inside that VPC, which is public facing, and it will automatically assign a public IP. Okay, so that using that particular IP, I can able to access the instance. So this is by default it uses the subnet setting. Subnet is setting by default, it is enables the public IP assignment. Now what I want to do is I want to create our own VPC, and I want to use that VPC for launching this instance. So that I want to place the EC2 instance within my VPC. Okay, let's go and create. So the one way of creating the VPC is you can come and create it from here, or you can directly go to the VPC dashboard. And once you go to the VPC dashboard, we get an option to launch VPC Wizard. Okay, so there are multiple steps are involved for creating the VPC, but there are few templates available which helps to create the VPC in a very simpler format. So what this is going to do is, there are 4 different templates we have. Okay, if I'm going with this template, VPC with a single public subnet, so I will be getting a VPC with one public subnet. That means only one subnet will be created with the VPC. Then this will create a VPC with both public and private subnets. Then the other one, VPC with public and private subnets, and also it provides the hardware VPN access. And this one, VPC with private subnet and hardware VPN access. Okay, so depends on which kind of a configuration we want. We can use this wizard, or we can also go for a custom VPC creation with providing the full details by ourselves. The one which I am creating now, it's like a, as illustrated here. So it's just going to create a public subnet, and whatever the instance I'm putting there can be accessible over the internet. Let's select. So you have to select the template of the VPC which you want to create, and as I mentioned, we need to provide the CIDR block. CIDR stands for the classless interdomain block, right? Interdomain routing, classless interdomain routing. So basically, this is for providing the addressing the instances we are putting inside the VPC. By default, so you can create the subnet mask as 16. That means 65,532 instances we can able to create. So currently they are not allowing to create more than that. Okay, so if you're just trying to create more than that, so it won't be allowed. Block size must be between /16 and 28. So minimum 8 instances and maximum 65,531 instances. Okay, so basically it will be 65,536, and 5 IPs will be allocated for other control and monitoring purpose. Okay, cool. So let me provide a VPC name, AWS VPC demo 1. So this is going to create VPC, and for the VPC, this is your so in the VPC I can have up to 65,531 EC2 instances. Then I'm going to create a subnet, and for the subnet I'm providing a specific mask. Okay, I can create if I'm going to create single subnet, I may just create it with /16 itself. That means I'm going to create a single subnet which is going to occupy the entire address, or I can create multiple subnets. When I say /24, so this is going to basically takes up 256 IP addresses. Okay, this is 2 to the power 8. So 32 minus this subnet mask. Okay, this 32 minus 16 is 16. So it will become 2 to the power 16. This is 2 to the power 8. Okay, then which availability zone I want to create the subnet? I want to create this subnet with availability zone 1A, and subnet name. So this any name you can provide. Okay, all right. Then enable DNS host name. Yes, so that the domain name will be allocated for the public address, and the hardware tenancy, and you can actually keep it default. When you make it dedicated, what does that mean is whatever that EC2 instance which I'm going to add inside the VPC should be a dedicated instance. Okay, so if it is a default, it could be a shared instance as well. So I'm going to create a first VPC, and so this VPC is just it's basically I'm creating a VPC with one subnet, and the remaining address currently I'm not using. I may come back and create another VPC later. Okay, so let's create a VPC. Okay, so VPC created successfully. Let me go to the VPC dashboard. So this is the VPC which I created. If you see, every VPC will have a unique ID. Okay, and what is the state of that VPC? And this indicates what is the CIDR block. So based on this only, the address will be allocated. Okay, then so this actually by default create few other things. This one of the important thing is the route table. This route table is basically provides the functionality of the router. Okay, if you go to the route table, it will be there here. So there is a route table associated with this VPC. If I go to the route table, so there will be a routing configuration provided in this. The route table will have a route specific unique ID. So what is the route configuration provided here? So what we are telling is whenever there is a request goes out from any of the instances running in this VPC, if the designation address is this 10.0.0.0/16, if the designation address of the request is any of this, the target is local, because it's the same machine. I don't need to go through any DNS. Okay, this indicates for the request going to the within the same VPC. So for example, if this machine wants to talk to this machine, okay, so I can able to make this communication possible only using a private IP. So each one will get a private IP. Okay, so in this, each of this instance will have the private IP. The private IP assignment is based on whatever the range we provided, and using the private IP itself, I can able to communicate within the VPC. Okay, I don't need the public IP. I don't need to do a DNS lookup. Whereas if I want to make this instance accessible over the internet, right, I need to have the request router to the DNS server. Okay, so to do the lookup, so that configuration would be there on the route table. Currently this has only the local the route table as the target only for the local instances. Cool. let's go back. Then I have network ACL. So with the VPC, there will be a network ACL associated. Okay, this network ACL, as I mentioned, you can actually control the traffic which is coming or going out from your network. Okay, so these rules will be applicable to all the instances running within this VPC. So the similar to security group, pretty similar to that, but the scope of this configuration is at a higher level. Security group is bounded to an instance level. This is bounded to the network level, the VPC level. Okay, so here I can configure, and also I can provide a configuration. This rule is associated to which subnet. Currently I have one subnet, it's being associated to that. Let's come back here. What else is there? This DHCP is basically for allocating the dynamic IPs. So every time I'm restarting the servers within that VPC, it will be dynamically allocating some public IPs, right? That rule is being mentioned as part of this DHCP options. This will be applicable only for I want to generate the dynamic IPs every time. So this we have seen: main routing table, main network ACL, and tenancy is default. Okay, and is it a default VPC? We mark no. We can also make it as yes if you want, so that every time the EC2 instance launch, it can use this as a default instance. Fine. Then I need to ensure one more thing. Internet gateway. Is it associated to internet gateway? So there is a internet gateway. Yeah. So the VPC is associated to the internet gateway. So if you see here, if you look at the diagram here, so what I have created is the public subnet. Okay, so in the public subnet, if I want to make this instance public, I need to associate this subnet to a internet gateway. So this is the internet gateway. So this internet gateway also created automatically, and this internet gateway has been basically associated to the VPC. So in the VPC, if you come and see, so the VPC comprises of subnets, route tables, internet gateway, DHCP option set, and the network ACL. Okay, the route table is one of the key thing. Then DHCP option set and network ACL, and CIDR block. So this is a CIDR block which has been allocated, and okay, cool. So the VPC is ready. So I need to ensure in the route table, the route association. So currently the route association is there only for the local target. We should also have that association added for. So when for a internet gateway. Okay, so what I'm doing here is, this is like a router. Okay, in the router I'm putting a rules. Whenever the request comes, whenever there is a request originated from one of the server running inside the VPC and it comes to the router, it will check if the destination is any of the addresses within this range. It will be doing a local forwarding. The request will be routed within the local network. If the destination is anything else apart from this, okay, then it will make use of the internet gateway. Using this internet gateway, it can able to access the traffic. Okay, save routes. Cool. So we have created a VPC now, and we have have the routing table configured, and DHCP option associated, and the network ACL configured. What is the default network ACL? So by default, it is allowing all traffic. Okay, I can either allow or dening. So currently I'm just allowing all traffic. Okay, so both inbound and outbound, I'm just allowing all. Okay, cool. Now let's come back here. So let me refresh this. If I see here, I got VPC. So whatever the VPC I created, I can able to see that here. Let me just select that. Then I get an option to select the subnet also. Okay, so I'm just using this subnet, and if I go back here, the subnet options also you can able to see. So this is a subnet which is got created. Subnet will have the details like what is the route table associated to this subnet, and network ACL specific to this subnet. Okay, so let me come back. So I just created only one subnet currently. I'm just going ahead and launching this instance. Okay, so this instance is going to be added into my custom VPC on this particular subnet. That means this instance will be added into Mumbai region availability zone 1A, and I'm enabling the public address. Let me just go ahead with the default configuration, and the security group. I'll just use the default security group. Okay, so the default security group is just allowing the RDP access for this, and launch this instance. I'm just going to choose existing key, launch. Okay, the instance got launched now. How do I verify that instance belongs to this particular VPC? You just go back. So it is the process of launching. Okay, so if you see here, the instance belongs to availability zone 1A. So how it become part of availability zone 1A? Based on the subnet which we selected while launching that instance, and also it has generated the public IP address. We'll just look at the two different IP addresses. One is the private IP. If you see, the private IP is something whatever the address range we provided. We provided like 10.0.0.0/16. That is like up to 256 we can able to generate. So whatever the range we provided, it's like I can able to generate the IPs up to from 0 to 255. Okay, so it has assigned an IP now, private IP, and the public IP is completely different. So this is using the DHCP protocol. It's just assigning this one, and using that the internet gateway, it is assigning this one. So now let me just verify whether I have a connectivity to the server or not, because now I have made this instance accessible over public, right? Let me say MSDC. Yeah, it is. I'm able to connect to this instance because it is ask me the credentials. So what I can do, let me just verify the credentials. So I got only the key. I need to generate the password. So using the password, so let me come back. So I can, how do I generate the password? Get Windows password, provide that PIM file. Okay, AWS key, Windows key. and it's decrypt password. I got the password, right? So I can use this password to connect. So username is going to be this. Right. Close this. MSTC. So either I can use this DNS name or that IP. I'm providing a DNS name. So when I'm going to provide this credentials, administrator, for the password got generated. Yes, I'm able to access this instance now. Okay, cool. So I'm able to log in into the Windows instance. So now if I just go back, so this is done. So let me just create one more subnet in the same VPC. Okay, so let me just let me launch one more instance, the same. Let me see how the address allocation happens. I'm going to launch one more instance. I launched one instance already. One more instance. So I'm launching the one more instance. I'm choosing this subnet whatever I created and enable this. Cool. Review and launch. Okay, launch. Fine. So this will be, so basically now there are two instances I created. So as you've seen here, maybe you can relate to this. So this is a public facing internet. I created two instances. What is the IP I got? For the first one I got 10.0.204. For this one, let me just go back to the EC2 instances. There is another instance running instances 2. Okay, so let me just check this IP. So if you see here, this private IP is 10.0.0.116. So that is, it won't be allocated sequentially within that particular range 0 to 255. It can allocate any of this address. So this one, the two launched, both are accessible over the internet now. So this one also got a separate public IP. Okay, so cool. So it happens. Let me go to the VPC. So I already have a VPC. Let me just go and try to create another subnet. Okay, so while I'm creating a subnet, I'm just making this as a private subnet, and this subnet I can associate with any of the VPC. I'm associating this subnet with this VPC, and again I can put which availability zone. This is going to be availability zone B, 1B. Okay, and CIDR block I can specify. So I already allocated something like, so here when I'm creating multiple subnets, right, I need to ensure the continuity of the addressing. So so this is the CIDR for VPC, and out of this what I allocated for the first subnet is 1.0.0./16. This is the entire thing. So this basically give me 65,500. Okay, sorry, 536. Okay, cool. So here when I'm going to this one I divided into a first subnet. It's basically 10.0.0.0/24. So that means this got 24 the 256 IPs. Okay. So when I say 256 IPs, it's nothing but 10.0.0. So this the range for this one is something like 10.0.0.0 to 10.0.0.255, right? So when I allocate this one, I have allocated this particular range. So total 256 addresses has been assigned for this subnet. Then the second subnet, what I need to do is I can't use the same 0 here because this is already allocated all the spaces. So I need to start freshly like this. And again, when I say 24, now what will happen is 256. And for this subnet, it will be allocated like 1.0.0 to 1.10.0.0.1.255. And if I'm going to allocate one more subnet, then the other subnet, it's already like, so the 2 is gone. Now I need to start with, so this each of the the individual value can go up to 255, right? So now it should be 0.02. So 256. Here I'm evenly distributing that, but this address can be like here it can be so cumulative value should not cross 65,556. So I can create as many subnets as I want, but that aggregate value should not cross this one. And again, during that 𝐶IDR block allocation, we should see there is no conflict or overlap. So that address is kind of coming continuously or sequentially. Okay, so so it will be like this: 1.0.2.255. Okay, so with this understanding, let me just assign this. This area block I need to provide for the subnet and create it. Okay, so the private subnet is being associated with this. Then if you go to the VPC and VPC, if you go to the 𝐶IDR block, so this is fine, this is the same. But if you go to the route tables, there are 2 route tables are there. Okay, subnet association. So what are the subnet? So this is created with the existing subnet association. I can also associate the other subnet. So both the subnets can be associated to this. Okay, and the association route propagation, those are fine. Cool. So that means this VPC has 2 subnets, and I have configured the route table to have both the subnets associated. Okay, then this is the 𝐶IDR range, and this is the route configuration. If in case I want a different route configuration for each subnet, I can have a separate route table. If I want same route configuration for both of them, I can use the same. Okay, it's cool. But in our case, this route configuration is basically enables to route it to outside, right? But I don't want this to be accessible over the internet, so I can just remove this. Sorry, it should be the other way around. Okay. All right, fine. So let's come back here. Let me going to launch one more instance. So when I'm going to launch another instance, so this instance can be anything, can be a Windows, Linux, or a Unix, does not matter. So only thing here, I'll be getting a different option. So there are two things. When I select this one, I should see the two subnets now. Okay. So I can choose to under which subnet this instance to be associated. So this will be disabled. Launch. So I'm adding an instance on another subnet. There are total two subnets I created, and first is a public subnet. I've added two instances under that. I have launched another instance. This one I am adding inside the private subnet. Okay. So if you see here, since it's a private subnet, the public IP is not generated. There is no public IP. This cannot be accessible over public. Only thing, the private IP. See the private IP address 10.0.1.54. So that is something like whatever I allocated. So this subnet series is, since this is 10.0.1.0, it's able to get this address. So 1.54, right? Yeah. And this one I can't be able to access publicly. But how do you access this one? This instance I can able to access from any of the other AWS instance running in the same VPC. Okay. So using that private IP, we can able to access that. So that is possible. So this just shows how you can create a VPC, how you can create subnets, and how do you associate the EC2 instance to a specific subnet while you're launching. Okay, and also we have seen the different components, what's there within that EC, when you're creating the VPC network. And so just to summarize, when it comes to the VPC security, so we have the instance level, we can configure the security groups, and we'll have a subnet. Then we have a network level access control. That network level access control will work for the specific subnet, whatever we created. Okay. Then we have a routing table. So this is a third layer of safety. In the routing table, if I have not provided the proper, like if I don't want to allow traffic to any of the unknown servers, that I can restrict in the routing table also. Okay. So this is how it works. So based on the routing table, this traffic can either routed to the internet gateway, or it can be just routed to VPN gateway, or it can be just resolved internally. Okay. So with this we'll just wind up the VPC concepts and the demo part. I'll just hand it over to SkillUp Spark to just give some updates, and following that I will just take up a Q&A.
Okay, great, Sarvana. Thanks for delivering such a wonderful webinar. So this was the last session. So totally we have done 4 webinar series, and some of the people have joined the sessions, from the last week, and today also we have a lot of new people joining in for the session. So I know people might be looking out for recordings where we will find it. Okay, so what I'll do is quickly I'll share my screen where you can actually find out the the recordings. Okay, so hope you're able to see my screen. So this is the web page we have created for you all guys, so that where you can go and actually access our recordings. Okay, so you can see that we have starting from 11th was the first session. So following 20th, 26th, and 31st. So all the three sessions links are available, Facebook as well as YouTube. Right. So today's session, once the session is over, within next 2-3 hours, we will be uploading, and you can come and access here. So quickly, what I'll do is I'll quick copy paste this link for you guys on the chat section so that you can go through. I mean, you can have it handy, and whenever you want the recording, you can go and access it here. So, and one more thing I just want to quickly update is, we are running a full-fledged training program. We have left with few more slots available. If anybody is interested to avail this discounted offer, actually our actual price is 13,800. We are, for the webinar participants, we are only giving a we are offering it at 4,956. So this is the price. So all the details are here. If you want to download the content, you can go ahead and download here. And to enroll for the program, here is the button. You can go and enroll the program, right? So one last quick update is all the recordings we have, updating on Facebook as well as YouTube. So you can subscribe our YouTube channel for all the latest updates. You get a notification, or you can follow us on our Facebook page, where anything related to AWS, we have created a separate web page called Master AWS with Skill Up. Anything related to AWS information, you keep getting over here. I mean, if you follow us. Okay. So quickly, I'll just paste the link on the chat section for you to keep it handy. Yeah. Here is the link, and also.
Hi Kumar, it seems people are telling that you are unable to see your screen. Can you just confirm it once?
Okay. Are you able to see my screen? Sarana?
I'm able to see, but I see some over the chat box, some chat messages saying that unable to see the screen.
Yeah. No worries,
Maybe
guys.
can you try to reshare? I'm able to see.
No problem. I'm just giving you the link itself so that you can yourself go and explore.
So guys, no problem. If you're unable to see the screen, don't worry. The link is being shared. You can follow the link to see that screen.
Yeah, perfect. And also on the top, you can find that AWS recording link. So above the chat section. So everyone, you're able to see?
Yes, I'm able to see.
So you can just click there and it will take you to the link. And also I suggest you to copy paste or bookmark this link so that you can go and find all the recordings, or you can go to our Facebook or a YouTube page for the further recordings. Right. So if anybody is interested, we have left with few slots for the webinar participants. So anybody wants to enroll for our AWS training, Sarana will be delivering. We are starting the program from 5th of September, this Saturday. 5 hours every day, Saturday, Sunday. 8 working hours is required. So Sarana will be delivering this session. So if you want to avail quickly, you can go and enroll for the program. Over to you, Sarana.
Thank you, Kumar. So all right, guys, we'll keep the forum open for questions. So if any questions you have on the topics we have discussed today or overall on AWS, you can post it. I'll try to give answers for your questions. Okay, so let me just check. Are there any questions already posted? I think, yeah, I got one question. Can you explain CloudFront and Direct Connect? From Gulnas. So Gulnas, basically like a Direct Connect is more like I have servers running in my on-premise data center, and I have few servers running on AWS cloud. I want a connectivity between these two servers over the network. Okay, so using the Direct Connect, we can able to make that connectivity possible. And how it's different from making that connectivity over the internet: speed and security. This Direct Connect provides more secure communication, and also it provides a pretty thundering fast. Okay, then when it comes to the the cloud front is more like I have developed a web application that I want to be accessible over the globe from a different location. So the cloud front is helping us to just create some cache at a different regions, so that even though you hosted your application in India, Bangalore, if some users are accessing from Europe or US, with the help of the CloudFront service, they can able to access our websites without much performance lag, with the help of the cache which is getting created. Okay, that is a very high level. Probably like if you want a little bit more detail, you can just go through that the Syrian links, the Syrian service, whatever is there in AWS. That will give you more detail how that's being achieved. At a very high level, if I want to just make your services accessible from a different location, and with the help of CloudFront, I can able to set up the distribution so that the content will be cached. It will help you to improve the performance uh, of your application, even though the users are accessing from different location. All right. And I got another question. Show the address. Any other questions? You can. Ah, that's a good question, Wilson. In terms of the pricing, there is a good news. So there is no pricing for creating the VPC or subnets. Okay. So you can create any VPCs, any number of VPCs or subnets. So only the price is going to be the instance which you're going to launch, EC2 instance. Okay. As such, for this VPC, there is no charge. But if I'm going to use the other things like virtual private direct connect, if I'm using a direct connect or a VPN service, there are some charges available for that. But whatever we have seen today, for that there is no price, separate price. Definitely, I think there is another question from Balu. Can we access AWS cloud services for free to explore for a few days? Definitely, you can able to access it and you can use it for a year. There is a free tier available. I think if you just listen the first webinar recording, you may get to know how to register an account. I have provided a detailed explanation of how to register the AWS account for free and use it. Okay. And any other questions, guys? You can post. And if you don't have any question, please provide a quick feedback on how do you find today's session. So was it informative? Have you learned any new concepts? And so overall, like in the series of 4 webinars, how much like you improved your knowledge on AWS? Was it useful? And share your overall feedback as well as today's session feedback. You can share your feedback over the chat. And meanwhile, if I just sharing few things, in case if you guys are interested to pursue your career in AWS, and if you are planning to get a certification on that, what are the different paths we have? Okay, so actually at a certification we have 3 different levels or 4 levels, I would say: foundational, associate, professional, and specialty. So the foundational is a cloud practitioner, so AWS certified cloud practitioner. So in this, the certified person will have the detailed understanding about the different services at a very high level. Okay, and when it comes to the associate level, we have 3 different tracks. One is like a solution architect track, so where the people who are coming from like an architecture background or a solutioning background, if you want to know how to develop the applications and deploy in AWS, building a the AWS certified solution architect will just enable you to design cloud solutions to be running on AWS. This AWS certified SysOps administrator associate level, this is basically like if you're going to pursue your career in a DevOps or SysOps administration side. Okay, so the people mainly coming from a administration background or a DevOps background, this would suit well. And the other certification is AWS certified developer associate. And so this certification is basically the people who are coming from a development background, so coming from a Java background, Java development, .NET, or JavaScript development, PHP, Python, anything, and want to just become a AWS developer and building some kind of services in AWS and programmatically accessing the service. You just want to become a AWS developer. So this track will be for them. And this is like the entry level is a foundational, then associate is a the next level. Then if you want to become a professional, okay, then you should go for a AWS certified solution architect. But if you want to become a professional, we should already have this certificate, solution architect. And similarly, you have a AWS certified DevOps engineer professional. So if you want to go for this certification, you should have either of this certification, either AWS certified developer or AWS certified sysops administrator. And if you want to pursue a career in a big data or machine learning or advanced networking, if you're coming from a networking background, I want to provide a solution for AWS networking, very advanced level. You can be a specialist on AWS networking. In those case, you can take up this certification. Right. Again, for taking up this certification, you should have a associate level. Then only you can go. You should have a professional level. Then only you can go for a specialty certification. Then either you can have a specialized big data expert, or if you want to become a machine learning, you can machine learning expert, you can take up this certification. So there are a bunch of machine learning services are there in AWS. So if you are well versed with those services, then this AWS machine learning specialty would be helpful. And similarly, if you want to become a security expert for building and securing the applications running on AWS, this certification is for you. Then if you're interested to build Alexa skills, this is for those people. Okay, so these are the different options. But very widely, if you see, if you're coming from something like a senior, you're a senior person, want to pursue a career with AWS cloud, probably this architect track would be suitable for you. If you are interested to design and architect applications and which can be deployed in a cloud, and you can configure the cloud highly scalable and more secure, and set up a load balancing and all those things. Whereas I want to make use of AWS cloud to automate my workloads, and I want to build a DevOps pipeline and take care of all the administrative activities, then this operation stream. And I want to build applications in AWS and develop a lot of custom programs leveraging the AWS services. Okay, I'm going to build a lot of AWS specific applications. Then the developer track would suits. Then you have a lot of other specialty tracks. So depends on your background and interest level, we can take any one of the track, and we have a very good demand in the industry currently for the people who are having a good experience with AWS, and also the people who are certified with AWS. We have a very good demand. All right. So just coming back as a final note. All right, Trika, you may go through just how this will. Yeah, so when you're coming from a testing background, you can actually align yourself to any of these things. Like you already have a interest on, so you can actually like something like a senior person. You can actually take up the solution architect so that you can able to expand your knowledge and start building applications on AWS. And and one more thing. So even for a tester, you don't want to build your career in AWS, but you're going to do a lot of development, like you're going to do a lot of cloud application testing. Okay, that basic understanding about what is a cloud and cloud apps, and this how to understanding these concepts and how these things are working will help you to do the testing of the cloud applications. That is more from a your domain perspective, or you can reskill or upskill you to become one of this particular track. Okay. All right. Where can I get submit an overall server knowledge? Sambota. So that actually you can. So that is something like a networking concept. If you just look out for the understanding of basic networking, how things are working, that will be you'll be able to get. All right, guys. So thank you very much for your wonderful time, and it's really a, a pleasant journey. And so thankful everyone for taking your time and participating in this webinar series. I hope you would have learned some new concepts and you got an idea about what is cloud computing and what is AWS and what are the key services are there. So stay tuned. Maybe we'll connect in some other junction. Until then, bye bye. And you may leave your feedback. And hope you may have enjoyed the sessions. Thank you, guys.
Okay, thanks, Sarvana.
Thank you, Kumar.
Yeah, right, Sarvana. Thank you once again. Okay, we'll connect back, Sarvana, later.
Sure. Okay.
Okay,
Bye.
I'm just ending the session. Thank you once again.
Okay.